and opinions expressed in this webinar are those of the individual contributor alone at the time of the webinar. They do not purport to reflect the opinions or views of IMIA or any entity employing or otherwise affiliated with the contributors. I will now hand over to Mike Spencer, who is the IMIA Secretary General, to do the introduction. Thank you, Mike.
Hello, everybody, and welcome to this webinar on project risk management in underground construction. Our speaker is Heinz Ehrbar, and he is graduated as a civil engineer from the ETH in Zurich, which is, I would say, Switzerland's foremost technical institute of technology university. He's worked on the Gotthard Base Tunnel, which was probably one of the world's biggest tunneling projects, with 57 kilometers of tunnel driven in very deep rock situation, and has worked on several hydropower projects, which is probably an area which interests insurers quite a lot these days, given the results we've had in the hydropower sector. One of the also interesting things I found about Heinz, which is quite rare for a tunneling engineer, is he speaks German, English, French, Spanish, and even a bit of Italian. So I think that's a bit of a different thing. For IMIA, this has been a very important area. It's been a 20-year story for us, which we started working with an organization called ITIG and the British Tunnelling Society, which is the British similar organization to DAUB, both of them affiliated to the International Tunnelling Association. And IMIA has actually issued a code of practice for tunneling works, which you can find as well if you're also interested in that, which is the EP62 on the IMIA website. So that is IMIA's contribution working with the ITA. So there is also actually mentioned in Heinz's presentation is the fact that the US have also come up with Underground Construction Association guidelines for improved risk management on tunnel and underground works. That's actually referenced by Heinz. So we've got a British code of practice, and now we're going to listen to some German-Swiss recommendations on a highly detailed presentation with a lot of work, 61 pages, I think, plus annexes. So it's been a big study carried out by the DAUB, coordinated by Heinz. So Heinz, let you start.
Thank you, Mike, for the introduction. Yeah. And thank you for the invitation. I'm very pleased to talk to you on this subject of project risk management in underground construction. And the agenda was already mentioned. I will give a brief introduction why we had to develop the DAUB recommendation. As it was already mentioned before, there exist other papers in the US, and the first one was made by the British Tunnelling Society, but we had certain reasons to create a national document in Germany also. And then I will explain some topics of these 70 pages, and I'm very pleased to have later on the discussion. So the German author Wilhelm Busch said once, firstly, things turn out differently, and secondly, never as you think. And as those pictures show from certain projects, Follow Line, Lötschberg Base Tunnel, and two pictures from the metro in Sao Paulo, this sentence is also valid, or we can use it also for underground construction. If you take the picture of the Lötschberg Base Tunnel, nobody thought that we could have such a water inflow in a tunnel which was built with an impermeabilization, but finally we had such a water inflow, and the train was rather dirty, and for the people it was not a very good experience to drive through this waterfall. And the other things are similar, very often an influence of water. So I think that's very important. As we mentioned already before, this the incidents in underground construction, they have a rather long history. Even it started with the major tunnels 100 and more years ago. There were several big catastrophes also in Switzerland. But if you have a look back during the last 30 years, we have certain examples from Munich, very well known in the UK, Heathrow, but also in Asian country, but also in Germany, Cologne and Rastatt were very big incidents. And the consequences in the most severe cases, we have the loss of lives, fatalities, and serious injuries. But very often we also delays in the construction program, and this creates also enormous financial losses. I think we are talking about tens of millions of euros or hundreds of millions of euros. So if you take the case of Cologne, this was nearly 19 years ago, and the line is still not constructed. Then impairment of third-party properties, and it can create reputational damage for construction methods, the contractors, the designers, and the clients. I remember very well that NITM was not a very good word during or after the Heathrow accident, or I was once in Taiwan where nobody wanted a TBM anymore because they had certain difficulties in a major road tunnel there. Risk events do not simply occur. That's something you know, but I think one has to remember this chain of cause, risk event, and impact. So risks, they have normally a cause and the risk event, which has a certain uncertainty. But if we have an event, then it has an impact and it has consequences on the project objectives. And the risk management is nothing else than to help to avoid the threats and to use or utilize the opportunities. And this starts with recognizing the causes and eliminating them as soon as possible, and then to minimize the probability of occurrence in the case of a threat, and to minimize and to control the impact of a threat. On the other hand, opportunities, we want to make use of it, and we want to promote the causes to maximize the probability and also to optimize the impact or to maximize it. These are some key issues. And what is very important if we are talking about the causes of risks, we have to talk quite a lot about human errors, because it is the main cause of such incidents. The Swiss Federal Institute of Technology, ETH, made 20 years or 15 years ago a study on more than 700 cases in construction, not only in underground construction, but it's very good, gives quite a good overview. And it starts with the objective hazard potential as 100%. And a certain amount of this potential is not known. This we have to agree also, that we don't know everything, but we should be aware about all the risk, but certain risk occur for the first time. This happens. Then from the objectively known, the part of this is not recognized by the people in the project team, and then the major part should be subjectively perceived. In the project, and this was my experience in several project teams, you start discussing about the risks, and then very early people say, this probability is very low, we can neglect it. And this happens that risks are considered or another part is neglected. So the definition of mitigation measures is only in this dark green area. All these risks here are suppressed by the organization. And I think that's very important to be aware about this mechanism. When the risk occurs and we have a definition of or prepared our mitigation measures, they can be good or they can be unsuitable, what we don't hope, but in certain cases it can be like this. And in the case of the incident, they must be used correctly. In certain cases, they are not used correctly or even not used. And safety through measures you have only if this entire dark green chain functions well, and the rest are human errors or incorrect human actions or non-actions. Or on this part, we have the risk where we say we don't prepare any mitigation measures, we accept them as residual risks. And finally, we have the force majeure also. From the 700 incidents which were studied in this paper of Professor Schneider, he saw that 75% of the incidents are related to human errors, and only 25% belong to the accepted residual risks. But if you have a look on the material damage or the personal damages, injuries, then we see that these figures are even higher. And I was very happy to see that the figures correspond very well also to your studies. I think 10 years ago, or a little bit more than 10 years ago, Mr. Reiner published these figures, and we see that the force majeure is in a similar range of 18%, and the rest lack of communication, insufficient ground investigation, defective construction, design errors. This is related to the human behavior. And I insist a little bit in this because in underground construction, we always see the ground risks. They are very important, but it's also very important that we are aware about these mechanisms of human errors and that we fight together the human errors. This is, I think, very important. As we were talking before with Mike, this is a long history, the cases you have seen already. But in 2006, the situation was like this, that I think the insurer said we are not able to insure underground construction anymore if there are not certain measures taken. And this was then the moment where one started with this code of practice, first from the British Tunneling Society, then with IMIA and ITA. I think in 2006 it was only the insurers, and then 2012 with ITA. And according to my experience, this is an excellent basic document. And as I mentioned to Mike, I was in the Swiss Tunneling Society in the executive board, and we had members there which said, if we have to follow this paper, we can't construct tunnels anymore. They didn't understand the importance of the message in this code of practice. And I think if you only follow this code of practice, you can avoid a lot of problems. So I think there was a very important input. But if you have a look on the national specifications on design and construction of engineering or architectural works, we have in Germany this famous HOIA. This is a specification for the services of engineers and architects, or in Switzerland we have the code SI 112. And if you take a PDF document and you start searching for risk or risks, in Germany you have 0, and in Switzerland you find the word risk 3 times. And I think this is this is completely insufficient. And this was the motivation for us in the DAUB, that we said we have to start once more with this topic and to promote it, that a very important task of engineering work is risk management. What is very important also is the hierarchy of the risk management, because after the bankruptcy of major organizations, Enron, I remember, or Parmalat in Italy, in many countries there were introduced legal requirements on the level of the company risk management, and these requirements from the legal part, they must be fulfilled. On the level below, on the risk management in the project, we don't have these legal requirements. One can say, okay, to fulfill the company level, we have to do something on this level, but there is a lack of pressure or something, sometimes also on documents, how to do this on the operational level. And finally, if we are going to the construction phase, I think there we have a lot of excellent documents on the processes, how to construct. I think there we have a good basic work, but here we thought we have a lack, we don't have sufficient ground, and we have to do something from the DAUB. And therefore we said we will produce something for the German-speaking market, not because the ETR paper is not good, but it was not very well known in the German-speaking countries. And we said we want to do something which can be included also in our contracts, or that we work like this. And we got also big support, I have to say, from the insurers, especially also from Munich Re, which helped us and supported us very much in this work. When we presented this work at ITA, the people said 70 pages, it's too long, can't you make a shorter version? And we produced this flyer, which you can also download, with the most important topics. And I think if you only follow this flyer in the projects, you have already done quite a good job. And this was our motivation. So the objectives and the target audience, it should be the recommendations are intended for everyone involved in the project, not only owners, but owners, designers, contractors, third parties, also experts, whoever, and for all phases in the process of a project development. And what we wanted to show is the imperative need for the phase-specific project risk management. I think during the entire cycle of a project, we have to implement the risk management. Then we wanted also to clarify the role, specific duties and responsibilities of the owner, designer, contractor, and introduce common and easy-to-use methods and tools for the project risk management. But because the focus must be on our site, and it shouldn't be too complicated for the management of the site. So the scope of the recommendations, it is principally usable or applicable for all construction works, not only underground construction, during all project phases, from the basic design until commissioning, and for all trades of civil works. If you go to the industrial processes, mechanical or electronics, there it might be maybe different, but for civil work it works. And it should also work for all contract models in construction. In general, one has to be, maybe one has to change a few things, but it is generally applicable from all contract models. The basic principle of project risk management is rather easy, but I want to show this picture here also because I was explaining risk management also to my students at ETH, and in the 7th semester of civil engineering, a lot of civil engineers or the students after the bachelor, they didn't hear anything about this general layout. And a project starts with a project idea and with the clearly defined objectives or requirements. And the idea is, if the project is completed, the requirements should be fulfilled 100%. And as we know, in between, we need a lot of processes, design, construction, also legal processes, tendering, everything. And we know that these processes, they have an influence of threats and opportunities, threats which can hinder the process, and opportunities can facilitate the processes. And risk management, the duty of the risk management is to define the measures to control the threats and to utilize the opportunities. It's quite easy, and I think it's a very basic principle, but as I mentioned, many of the students in the 7th semester, for them it was a new message. What is also important is the curve of the knowledge gain in a project. If we work with traditional tools, what we don't do anymore, but then we have this sawtooth curve each time or at each moment where we have a change of the team in the phase of the project, or new people coming to the project, we have we lose a certain amount of knowledge, and this creates this curve. And the gray area behind is the missing knowledge or the uncertain knowledge. And the task of the risk management is to minimize this green area. We can't avoid that we don't see certain things, that we have unrecognized things, but we have to create a big green area with the controlled risks by the methods of the risk management. And we have to also define the line where we say, okay, we know the risk, but nothing has to be done. And then we have quite a clear idea how to manage our project. And I insist it is very important, because if we don't do risk management, we have the picture as seen here. And if we start with the risk management at a very early phase of the project, then we have a by far better knowledge of our project already in the design phase, and we have less problems in the construction phase. It's maybe nothing new, but my experience is, if you are talking in project organizations, very often there are risk management, we do it later, and it hinders us to work quickly. No, it's the other way around. This process here is very important. So our recommendations of the DAUB, they follow the very well-known process of ISO 31000, and the chapters in our recommendation are the individual steps of this process, and I will explain what we did in our DAUB recommendation. The first thing is establishing the context, and this is also something where one has major discussions in many project organizations, but it's very important that you establish your project context, which are the influencing factors external to the project: environment, law, state of the art, economic environment, local conditions, knowledge, research, what do we know, what we don't know, ethics, moral, but also the stakeholders are very important, the external stakeholders. But we have also the project internal factors, human material resources, then also the internal stakeholders are very important. And in this system, we have a certain interaction, and this is very important that we organize this interaction, the communication, and also the measures to avoid risks. And yeah. Very often one is discussing about the causes, and you can find in the literature quite a lot of catalogs of cause categories. We made a compromise of this literature and defined, also based on the German experience, these 14 cause categories. And as you see, we have the ground conditions here, and we have the force majeure and natural hazards, but the rest, so the rest is all related more or less to the behavior of the project team. And this can have an influence on the project requirements also there. Very often one is talking about only cost, time and quality, and we created a catalog of 11 important project requirements for underground infrastructure projects. This is an idea how one can do it if one has other requirements in the project. This is not a law, but it should help that one creates a system that doesn't forget the important things. That's the main idea behind this 14 to 11 matrix, but it shows already that it's rather complex if we want to have a global overview on all risks. Then the process starts with the risk identification, and this is very well known. We have a lot of different tools, from workshops up to interviews, literature study. What is my personal experience, and I'm a little bit frustrated about this, at least in the German-speaking countries. At the Gotthard base tunnel, we had risk registers in the most complicated cases with about 400 risks in the risk register. And when the tunnel was completed, this went to some archives, and nobody was interested in these risk registers where you have a tremendous knowledge base. And I think one should evaluate existing risk registers, or have a place where I can find such registers, and then everything becomes a little bit easier. Or also the exchange of experience with similar projects, I think, is very important. So our recommendation is not to do only one thing, but to make a selection of several of these methods, which is most or is the best for the own project. The analysis, there are big discussions, but we said we make the focus on the semi-quantitative method, where we are quantifying the impact. Normally you can quantify the loss of money, or what is the impact on the construction schedule. This you can quantify. But what we think in many cases, we don't have a database to quantify the probability of the occurrence or the likelihood of an incident. And there we think it's more honest to make it in classes, where you say it's very low probability, low, medium, or high, according to the experience, and not making figures with 3 commas behind with 3 figures behind the comma for the probability. This shows an accuracy which has not a scientific base, we believe. And then we have to make the assessment which risks are accepted, which are not accepted. We have to produce the acceptance line. This can be different from this example, and it's also not said that it has to be a 4-to-4 matrix. We worked at the Gotthard only with 3-to-3, and it worked very well. I think each organization has to make the decision which is the best system, but we think the semi-quantitative method is very good for the site management also. I think it's not too complicated. And finally, we are not against quantitative methods and with methods also with Monte Carlo simulations and such things, but we think this method should be used for specific questions, that it makes sense, as it shows here the estimation. I think it's of the example is of the Lyon-Turin tunnel, the TELT cost, probable cost, and time scenarios, or we made such a study also for the final breakthrough at the Gotthard base tunnel. I think this, for such specific questions, it makes sense. One moment, please. In the video conference. So how to implement the whole thing. The risk register is the most important tool, I think. This is the key management tool. It's rather easy, but I was surprised you don't find the word risk register in the ISO 31000. So we made an example, and as I showed it in the daily business, it will be a little bit more complicated, and it's very helpful if you use the IT tools. There are excellent databases on the market. The options for action are also very well known. I think one has to avoid by the design and the planning process to reduce the protective measures and emergency organizations, and you can transfer risk by contractual agreements or insurance solutions. And as it was mentioned before, we have also a stock of accepted residual risks, and with this we have to manage our projects. We made a generic recommendation how to avoid risk and how we can reduce risk, or which are probable solutions for transfer of risk. We have written this, but one has to do this by daily work in the project in a more detailed way. But what is very important also is that we know that we have different types of action. We have to bring the appropriate resources to the project. We have to bring in the material measures, the right material, the installations, and the good material. But very important is also the organization. And I think this is something that is not always considered on this level as it should be, but I think it is very important to have this organizational measures also for ICE principle, for instance, or expert teams or standby task forces and such things. I think is very important to avoid or to reduce risks. The communication of the risks is very important. As I mentioned before, at the Gotthard base tunnel, we had 400 risks, and this you can't explain the 400 risks to the top management. And this figure is, or this picture is based on the experience of German railway, where they say which risks have to be communicated to the management or to the top management, and which is daily business on the project level. I think this is very important. The top management must know the major risks of the major projects, and the tunneling construction is normally normally major projects. So this is very important, that we organize also the communication of the risks in a good way. And if we have a simple method, or comparatively simple method, then it's also comparatively easy to communicate the risk. This is one standard diagram we used at the Gotthard base tunnel for the cost and time risks at the Gotthard base tunnel. You can also show in this diagram how it was 3 months before, and the director of a company can understand such a diagram. And I think it's very important. And you can even remember which one is in the red field or in the dark green field. So I think it's a very helpful tool also for top management level. What is very important also is that each risk must be countered with suitable measures, and we have different types of incidents. We have a sudden event without warning. This can occur, especially also in tunnel construction. We had such a case, I think 3 weeks ago. You find it in the internet, where we had a tunnel collapse in the mountains in Switzerland, a sudden event without any warning before. Yeah, it shouldn't occur, but such things occur. Then we have things where we have an initial warning, or other processes where we have a slower process, where we have the possibility to follow the development of this incident. But what is very important, that we have the monitoring system, that we have the attention values, the intervention values, and where do we have to act immediately, alarm values or immediate intervention values with the corresponding measures. I think that's very important that one does this. And maybe it sounds also easy, but if I know projects where there is a lot of monitoring and it's not quite clear who has to interpret the results and who is responsible for for taking the measures, and this is part of the risk management, as everything is clear. But nevertheless, we know that risk can occur. This is a rock burst event in the Gotthard base tunnel. Such things can occur, and then if you have the incident, then you need emergency management. Later on, if you have the first hours or days after the incident, we have still a crisis on the site, and you need a crisis management with very often additional knowledge or additional support until you can go to the continuity management. And in such cases, especially in the case of severe or heavy incidents, it's very important that you have a clear communication. And I observe or follow certain cases of such incidents, and I think it's very important that you have a clear strategy of communication. The one voice principle, I think the worst thing is if 3 people or 4 people talk within 3 days on this incident with slightly different opinions, and this is very bad against the authorities, but also against the public, and this must be under control. And we followed at the Gotthard base tunnel this process here. The responsible was the communication officer with the CEO, with the executive management, and they took the decision whether we needed an additional task force for the crisis management. And for certain cases, we had standby task forces, and we used them also. And I think this is a very good principle. Now, what I was telling until now was more or less all is applicable for all type of construction. But
Heinz, just to interfere, you're 10 minutes over the planned time. How much
okay, I will finish. I'm in the last slides. Yes.
Okay.
So
right.
Here we have I wanted to show that we have hazard scenarios. This is typical for underground construction. And very important is the responsibilities. And what is quite clear, the client is the first to come into the contact with the project, and he must initiate the process. And this is very important, that the client or the owner takes this role, and he includes all the internal participants and the external participants. And they must be integrated. I think that's very important. And for finishing, we have also a table, you find it in our document, with the goals of the risk management, the most important goals of the risk management in each phase. And I want only highlight one, which is also sometimes under a little bit under pressure. It's very important that the results of the risk management, the findings on the client side, they must be presented during the tender phase also to the bidders. It makes no sense to hide the findings of the client's risks analysis. And there's sometimes one has major discussions, but we insist that this is a very important task, and the other things we can discuss later on. So I'm at the end of my presentation, and please support the implementation of the project risk management, so that in the future we no longer fall short of what we have achieved, but on the contrary, that those to come do even better than us. And this is a sentence from the breakthrough of the Simplon tunnel. This was the longest railway tunnel, 9,005 of the world, and this was a sentence mentioned by a member of the board of directors of this organization, and I think it's still valid for today. So thank you very much for your attention.
Thank you, Heinz. I'll start with one question. I thought very relevant to what you've just said in red, and that how does the recommendations will stop clients thinking that they're saving money by not releasing their risk analysis to the contractors during the procurement period? They feel that if they don't release the risk analysis to the contractors, the contractors might think it's an easier job than it really is, and get cheaper prices. How do you stop that kind of
I think it's a topic of the culture. How do we work together? And if a client thinks that by not mentioning his own risks, he has an advantage, then the contractor during the tender phase says, "Oh, I've seen certain risks. I will also not mention them." Then we have this famous situation. And I think this is really a change of the culture, how we are working together. And in the German-speaking countries, I think it's a difficult process. We start now with new contract models, more based on alliances. Maybe this helps with open books, and we work together. But if the client has still in his mind, "I will not tell the truth," you have to change the people, I think, finally. Because
okay,
also in the organizations where I was working, these were always big discussions. They said, "Oh, if we mention this, no, this is bad." At the Gotthard, we mentioned everything. Even we mentioned to the contractor, "You are a certain risk with your claim management," and it worked very well.
Right. Okay. I think that is best practice. So I've got a question here. It says, I think this is using the IMIA loss experience. 41% of tunnel loss experience comes from design error, which is separate from insufficient ground investigation, which is, how is this figure so high with so many international design standards and code of practices published?
I don't know whether
I don't know
somebody from Munich Re is here. This was the study of 2011, published, I think, in an event in Amsterdam, but I was not present there. And I thought that the figures are correct, but what is behind in detail, I can't explain.
Yeah. And the second question this is also from Allianz, from Lee. Many times project teams, contractors carry out risk assessments and come up with mitigation measures. What is your view of the balance between underestimated residual risks versus the efforts, resources required to tackle the risks, which often comes down to cost again? So how do you, as I understand that question, it's how do people balance the idea of reducing probability of loss by spending money? So how does the whole, remember we're us insurers, we're from the financial services background, so it's the cost versus the reduction of risk. How do you balance the two? How does it work out in practice on projects? So if you have a huge amount of expenditure to reduce a project risk, do you do it or not? And how
I think this is also a part of the culture. And as long as you are in the red area, you have to do it. I think that's quite clear. Because I don't know what happens if you have such an incident and you have a court case or such things. Then I think it's very bad. In the middle area, in this orange area, it's this famous as low as reasonable, practicable, as long as I can reduce the risk amount more by my investment, I should do it. And I think that's the way we did it in many cases, because, for instance, in underground, what do you have to do? You have to prepare grounding measures or special equipment and such things. It's not as expensive compared to the costs of an incident. And then you do it.
Talking about grouting and things like that, what do you think of the implementation? Would you agree with it? We should be recommending implementing things like queue systems and baseline ground conditions into contracts? Would you recommend?
There are several approaches. In Switzerland, we are not very, and also in Germany, we are not very. We don't follow too much these queue systems and Ehrbar and such things. We work with real hazard scenarios, and I think it's the better approach to have the list of the real scenarios, and there you can you have to define the mitigation measures that you can work against these hazard scenarios. With a figure, an Ehrbar value or a Q value, it's rather difficult to define the right mitigation measures. Therefore, we recommend to work with clear hazard scenarios also in the contracts.
Yeah, but the Q system is not only used for evaluating risk, but also for evaluating cost. So for having a variable cost, so that the contractor, when he's coming into different types of ground conditions, he might have a different price per meter of tunnel.
But that's my personal opinion, as it was said at the beginning. I'm not sure whether this is the right approach, because once I was at an international conference where a lady presented one curve that I had a Q value, and then I knew the costs per cubic meter or per meter tunnel. And I asked, where do you have these values? Yeah, these are 160 projects from Switzerland where I know the database, where I say even the database is not that stable that you can create such a curve. So I think the project specific approach with really listing the risks and also the ground behavior and the hazard scenarios, according to my opinion, it's the better approach than maybe in a very early stage one can do those things, but they are not very accurate, I think.
Thank you. I haven't got any other questions. Stephanie, have you got any
yes,
questions?
Mike. Excuse me, sorry, Mike. I see two more. They've pushed up. Shall I read it?
Yes, read it because I can't see them. Yeah.
Okay. Right. Do you support the approach that the client's risk registers are part of the contract documents? And what approach does the guide provide in relation to managing cost and schedule contingencies as the project progresses?
It depends a little bit on the contract model. For instance, in the case which I know best, Gotthard-based tunnel, we had the major risks in the contract, and later on, in the contract, we agreed that we will prepare together the detailed risk register, and we gave this to the contractor. And if you are working in an alliance contract where you have also to include a certain amount for the risks, there you have to work together during the tendering process, and you have to develop a common risk register also with the financial consequences. And I think that's the best approach.
Okay, thank you. There's another one. In many cases, clients don't even know what the exact challenges are. In many cases, a lot of final soil investigations and final designs are completed during the early stages of construction. What do you do then?
Yeah. One thing is dealing with the ground risk. I think very important is also the concept how to explore the ground during the construction. But I think there are also figures available. What's a reasonable amount of costs which I have to invest for an early ground investment? If I don't do it, I have those risks. And I think one thing more, one should be honest also to the contractors or to the design engineers. If one didn't do the job right, one has to know that we have higher risks. And maybe commonly one takes the decision to invest more in the ground investigation. But I think there are certain figures where one knows what has to be invested.
Thanks. Looks like we've got two more questions. The next one, most of your collapse examples refer to rail projects, yet we see many losses on hydro tunnel projects. Please could you share your views on how hydro project risks differ from urban infrastructure tunnel projects?
Yeah, okay. As I mentioned, I was working during 15 years in hydropower, and we had also such cases in hydropower construction. I think very often there you have problems with water, with fault zones and water inflows, big inflows. And very often you have smaller diameters in a tunnel than you have for a railway or a road tunnel. This makes it more difficult to deal with the risks. But the system, I think, is the same. You have to have your project-specific risk register, and with the mitigation measures. But what I agree and what I observe is that in the hydropower field, in general, I think people do a little bit less than in traffic tunnels. But they have to learn it, how to do it, I think. When I was working for hydropower plants here in Switzerland in 1990s, also 5 years before I came to Gotthard based on, we didn't have risk registers. We introduced this with the traffic tunnels.
Yeah.
Okay. Everyone who's writing in is saying what an excellent presentation it's been. So thank you. So another one. Have you got time, Heinz? You happy to carry on?
Yeah, I have no problem. Yeah.
Oh, great. Okay. Unknown ground conditions seem to be a major risk. Are there any new methodologies which mitigate the risk and improve the assessment of ground conditions? There's a few questions to this.
Yeah,
Any ground condition libraries available? And could AI contribute to this for predictions or early warning signs?
I think possibly increased instrumentation as well. Could that help?
I think it depends once more on the project and also on the hazard scenarios. For instance, this phenomenon of rock burst, which is a sudden displacement of parts of the rock, like an explosion. You can't measure this by experience of the ground conditions or by the first incidents. You know this will happen. Other things you can monitor. If you have a squeezing rock, the deformations you can monitor and you see whether I have to act or not. So I think it depends really on the ground conditions of each project and also on the size of the project. If you have a base tunnel through the Alps, as we had at the Gotthard, if the government is not willing to invest in an investigation gallery, you don't know what is in front of you. You have some investigations, some boreholes, maybe 20, 30 or more, but you don't have a general overview, and then you will get some surprises. At the Brenner Base Tunnel, for instance, there they had in parallel an investigation gallery. This helps already. So I think it's very important that you have a clear concept on the investigation in advance of the excavation, and this concept must be quite consistent. But if you do the best way, then you have also to invest money. But according to my opinion, it's a good investment if you can use this investigation gallery, for instance, also during the operation. Then it's paid back easily. And there is still a lot to be done, I think, in our project.
Okay,
thanks.
I think we'll bring it to an end. That was a very excellent presentation. Thanks for giving all your years of experience on tunneling projects and helping us insurers, giving us a picture of the risks involved in this difficult area. Hopefully some of the audience will be reassured by the fact that there are engineers who are looking to reduce the risks and coming up with processes to do that. So thank you very much, Hans, for your presentation.
Thank you all for participating.
Yeah.
Thank you very much. Okay.
Thank you.
Okay, bye.